Hey y'all, I'm at the beach again. Review for exam number 3, Unit 3. So on Unit 3, you are going to type out your vocabulary words, type out the definitions, study guide for me, type out the questions and the answers, and then type out the essay questions and type the answer out. So let's do this. Beautiful day here. Okay. What are mid-ocean ridges and what occurs there? Mid-ocean ridges are where there's crustal divergence underneath the ocean, where two plates are pulling apart from each other. What happens there is new crust forms. Magma makes its way up from below the surface and it solidifies and forms new crust. There's also an undersea mountain range, about 40,000 miles long, called the Mid-Ocean Ridge System. Igneous rock is any rock that has cooled and solidified from a molten state. Sedimentary rock forms from eroded materials that are deposited into layers by like wind and water and then cemented together. Metamorphic rocks are rocks that have been altered or changed by heat and pressure. So the next question, be able to categorize all the rocks discussed in class? You don't need to worry about that. We're not going to do that question. Mass movement, and know some examples. So mass movements, mass wasting is the slow downhill movement of soil and rock in response to gravity. So some of the more rapid types are like landslides. They would be like mudslides, rock slides, or something called a slump, which Jackson is in, my son, with the ladies right now. It's very, very sad. The slower types are creep, which he just told me that's what I am. Creep's extremely slow downhill movement of soil and rock in response to gravity. Solar flexion happens in high altitudes and high elevations. It's kind of a freeze-thaw cycle as materials slowly make their way downhill. It's pretty bright out here for this albino. I'm going to have to put these sunglasses back on here to be able to survive out here. Characteristics of normal, reverse, thrust, and strike slip faults. A normal fault is caused by tension in the Earth's crust. So the crust is being pulled apart like this, and there's vertical motion involved. Reverse fault, there's compression going on in the crust. So one slab of crust is thrust up over the other. There's also vertical motion. A thrust fault is a low angle reverse where one slab of crust kind of thrusts up over the other. And it may be several miles down, and when it does happen, the movement, maybe the hills up above can go up a few inches or maybe even a couple feet. A strike slip fault, the movement is primarily horizontal. An example of that would be the San Andreas Fault. Okay, some plutonic features. So, Morro Rock here at Morro Bay is an example of a plutonic feature. It's about right over there in that direction. So that was a volcano at one point. Everything's been eroded away except the material that's solidified in the vent, and that's what's left. Morro Rock, a volcanic plug. Also, dikes, sills, laccoliths, and batholiths are all good examples of plutonic features. What volcanoes make up the core of the Hawaiian Islands? That would be shield volcanoes. Okay, so maybe 7 big shield volcanoes make up the core of the Hawaiian Islands, right? The core of the Big Island, at least the Big Island of Hawaii. 7 shield volcanoes kind of mushed together. Crater Lake is now a caldera. Before that, it was a gigantic composite cone volcano that blew its top about 4860 BC. I think I've told you I've been through several lifetimes. That was back in my 23rd lifetime when that eruption took place. And it was such a big eruption, I guess it's estimated to be 42 times as violent as the Mount St. Helens eruption was of 1980. It blew the whole top of the mountain off and left a hole in the ground called a caldera. So a caldera is a volcanic crater greater than 1 mile in diameter, and Crater Lake sits inside of a caldera. Horst and Grabens. By the way, you're going to skip the question on order of events. So Horst and Grabens. A horst is a block of crust between parallel faults that's gone up compared to the land on either side. A graben is a block of crust that's dropped down between parallel faults. Those are German words. So a good example of maybe a horst would be the Inyo White Mountains. That's the next mountain range out to the east of the Sierra Nevada. Grabens, that would be the Owens Valley, the next valley to the east of the San Joaquin. And let's see, Lake Tahoe, I believe, is a graben also. Two basic categories of weathering are physical weathering and chemical weathering. Root wedging, frost wedging, exfoliation are all good examples of physical weathering. Root wedging occurs when a seed gets in a crack or joint of a rock, and the seed germinates, and the plant or the tree begins to grow. As it does, the roots can break rocks apart, even rocks as strong as granite. Frost wedging is when H2O gets in a crack in a rock, and as it freezes, it expands about 9% or so and exerts a pressure of about 2,000 pounds per square inch. So freeze thaw, freeze thaw, freeze thaw can break rocks apart. Exfoliation is the sheeting off of concentric rock layers. A rock like granite is an intrusive igneous rock. It forms below the surface of the earth. So when glaciers come along, like in the High Sierra, or when rivers have flown over the years, they've eroded away the topsoil and the top layers of rock, and the granite gets exposed, and it expands outward and it sheets off, kind of like peeling an onion. Exfoliation, sheeting off of concentric rock layers. What causes exfoliation? It's something called unloading. That's where the weight's taken off of a rock like granite. The Mercalli scale is used to determine earthquake shaking intensity. It's a very old scale. It uses Roman numerals 1 through 12. Anticlines and synclines are associated with folding. So an anticline is an upfold, a syncline is a downfold. Where you guys might have seen these is on your trip to the valley or back from the valley as you go past Kettleman City towards Paso Robles. Lots of upfolds and downfolds. Upfolds are anticlines, the downfolds are synclines. They're caused by compression in the Earth's crust. Some lines of evidence used to support the theory of plate tectonics: the fit of the continents. You've maybe seen a map before and you've recognized that, South America and Africa appear like they might fit together like puzzle pieces. Well, there's pretty good evidence that they were connected together over 200 million years ago. So fit of the continents. There's fossil evidence, lots of that. A little critter called Mesosaurus, a little reptile critter. Fossilized remains located in rocks dated to be close to 225 million years old, found both in South America and in Africa. And how did that little critter get from one continent to the other? Probably had about as much a chance of swimming across the Atlantic Ocean as Big Dave here. Just not going to happen. Seismic evidence, volcanic evidence, lots of lines of evidence used to support the theory of plate tectonics. Let's see where I'm at on here. Okay, understand the Richter scale. The Richter scale was developed by Charles Richter at Caltech back in the 1930s, I believe, and it looks at the energy released in an earthquake by looking at the amplitude, how tall are the S waves. When you have an earthquake, the earth gets squeaked in different ways. So you can have compressional waves and you can have transverse waves that kind of go back and forth. The S waves are transverse. And so on a seismogram, the piece of paper that comes off the seismograph drum, you can look at the amplitude of the S waves. All right, let's see here. The moho is the boundary between the crust and the mantle. It's been determined by seismic studies. So I flipped it over, maybe you're on the other page or the next page. How do island arc chains form? An island arc chain would be something like the Japanese islands. So they form when one plate is diving beneath another underneath the ocean. Some oceanic crust subducting beneath other oceanic crust. That material heats up possibly and melts and comes to the ocean floor. And then over time, it forms little undersea volcanoes, seamounts, and they grow, pop their heads above water, and now we have Japan. So a great place for earthquakes, like in 2011. Okay, let's see here. Understand the term half-life. Half-life is the time it takes for one half of the atoms of a radioactive substance to decay. So using radiometric dating techniques, geologists can try to determine how old rocks might be, or how old the earth is for that matter, or how old things that were formerly living are using like carbon dating. So something like carbon dating, the half-life is like between 5,000 and 6,000 years, right? The time it takes for the the atoms of carbon-14 to decay into a stable form of nitrogen. So the time it takes for 1/2 of the atoms of a radioactive substance to decay. What kinds of faults produce fault scarps with the most vertical relief? A fault scarp is a hill or a bluff or even a mountain face like the east side of the Sierra Nevada or the east side of the Grand Tetons created by earthquakes. So you want the faults with the most vertical relief. Those would be normal faults and reverse faults. The Hawaiian Islands are forming as the Pacific plate slowly moves over a stationary chamber of magma called a hotspot located in the mantle. So as the Pacific plate slowly moves over the top, right, you get a string of volcanoes forming. So the Big Island of Hawaii is currently pretty much over that hotspot, and that's why Kilauea has been so active since about 1983. So it's the movement of the Pacific plate over a stationary hotspot embedded within the mantle. What kind of plate boundary is represented by the San Andreas Fault? That's a transform boundary. That's where one plate is sliding beneath another. So the San Andreas Fault is the boundary between the Pacific plate and the North American plate. My students, you guys are over at COS. You live on the North American plate. Over here, the Cuesta students and myself right now, we live on the Pacific plate. In case you're interested, you cross over on your journey near Shalom, that area where James Dean kind of bit the dust years ago. Let's see, what is creep? All right, that's extremely slow downhill movement of soil and rock in response to gravity. What determines the rate of mass movements? Gringo like me, it's how much Mexican food I have, you know. Still blows my doors off, but mass movements in terms of geology, that would be how steep is the slope and the addition of water. Water can saturate a hillside, make it heavier, can lubricate the hillside also. How do rift valleys form? They form by crustal tension. Two slabs of crust pulling away from each other. The best example in the whole world is in East Africa. It's called the East African Rift System. Has the Somali subplate, or that eastern part of Africa pulls apart from the rest of Africa. It forms all those long skinny lakes that form in that rift depression. Okay, so it's a valley formed by crustal tension. The Himalayas are forming as India collides with Eurasia, has two tectonic plates. Continental crust collides with continental crust. And your hands on a tablecloth, bring them together. You get some nice wrinkles. The Himalayas are some big wrinkles and it's still going up. How is the distance from the epicenter to a seismograph station located? By looking at the difference in arrival of P and S waves, primary waves and secondary waves. So remember, when we have an earthquake, the earth gets tweaked in different ways. There's compressional waves and transverse. So the P waves travel faster, maybe 1.7 times faster depending on the rock type. So you look on the seismogram, the piece of paper that comes off the seismograph, and you look at the difference in arrival times and mathematically figure out how far away the epicenter might have been. Can faults occur in the same general areas folding? Yes, of course. What kind of plate boundaries is volcanic activity the most prevalent? Divergent boundaries like in East Africa are convergent subduction boundaries like we have along the west coast of South America forming the Andes, Pacific Northwest of the United States forming the Cascades. The Japanese islands, the Aleutian Islands, the small islands of the Caribbean are all created by subduction, plate convergence, and then one plate diving beneath another. Tsunami is a large ocean wave created by an earthquake, a volcanic eruption, or a landslide. Don't worry about the relative dating problems and the cross sections. The essay question, so go to the link, take a look at the map that I put on there for you, and look at where the earthquake epicenters are located. So first one, part A, explain the theory of plate tectonics. Plate tectonics is the idea that the outer shell of the earth, the crust, the upper boundary of the mantle, is broken up into maybe 12 big pieces and lots of small pieces, and they move around. They can diverge, which means pull apart. They can converge, which means laterally slide by each other. They can diverge, which means pull apart, converge, where they come together, or they can laterally slide by each other. Okay, we think the plates move probably because of convection currents within the mantle of the Earth. Are earthquakes concentrated in any particular areas? Well, they sure look like it to me. Along the west coast of California, near Mammoth Mountain in the Eastern Sierra, and a lot of areas, Eastern Sierra, and some areas of Nevada. So why are they concentrated in these areas? Well, the west coast of California is the boundary between the Pacific Plate and the North American Plate. That's the San Andreas Fault. So the Pacific Plate to the west of the fault is slowly moving to the northwest at an average rate of maybe 2 to 3 inches per year. Now it doesn't go 2 to 3 inches every year. Some years, sometimes it may wait 200 years and make up for lost time and move like 30 feet. That's when you have major earthquakes. The quakes near Mammoth are probably created by the movement of magma below the surface. Back in like 1980, we thought Mammoth was even going to blow its top, but that magma chamber fortunately subsided. So the movement of magma near Mammoth. And a lot of those quakes out in Nevada, eastern Sierra, are caused by crustal divergence. The United States apparently is being pulled apart through the Great Basin area there, the Nevada area, resulting in normal faulting. So you can get earthquakes there also. So I think that's about it for Unit 3. Do a great job on this. Let's have lots of good grades.